Hello students, in this lesson we again derive the line of regression, but this time we derive in terms of regression coefficient. We derive from arithmetic mean of x and y. We have already derived normal equation for regression line y on x. These are the normal equation. Now look at this normal equation too. If in this equation we divide by n, so we see summation of xy by n, a summation of x by n plus b summation of x square by n. From here we try, this is summation of x by n is x bar. We substitute the value of this one and we substitute the value of this one in terms of covariance and variance, and we get the value of this b. That b is the regression coefficient y on x. So let us start. We know covariance between the two variable x and y is 1 by n summation of xy minus 1 by n summation x multiplied by summation y. Now from here, in our formula, summation of x by y by n is involved. So here it is summation of xy by n. We get the value of this in terms of covariance. So this is equal to covariance plus minus, it goes to other side, it becomes plus 1 by n multiplied, so this becomes 1 by n square summation of x summation of y. That means we get the value of this, that is equal to covariance xy plus x bar y bar. Now with the help of variance we get the value of summation of x square by n. As variance is equal to 1 by n summation of x square minus 1 by n multiplied by square of summation x. So again we try to find out this value. So this is equal to, that implies summation of x square plus, now this is summation x square and it is n square, so summation of x by n is equal to x bar, so this becomes x bar square. Now using this value and this value we use here, and this is equal to x bar, so the result is we substitute this value, covariance xy plus x bar y bar is equal to ax bar plus b times this. Now we just multiply, this is ax bar plus b x bar square and this is b sigma x square. But we know y bar is equal to this. That means if I multiply both sides by x bar, so we are having x bar y bar is equal to ax bar plus bx bar square. So ax bar plus bx bar square is equal to x bar y bar. So this portion is these two terms, the sum of these two terms is equal to x bar y bar. So these are cancelled from both sides. So you are left with covariance xy is equal to b sigma x square. So we have the value of b, covariance of xy by sigma x square, and this is the regression coefficient y on x. But again now we see, if we divide and multiply by sigma y, then what you are having, we just rewrite it. We write sigma x on this side, so this is sigma y by sigma x, this becomes sigma x sigma y, and we know this is equal to what? This is equal to r, and Carl Pearson's coefficient of correlation, this is r, and this is sigma y sigma x. So this is the value of b. Now this b is the slope of the line. You can see y is equal to a plus bx. What is the slope of this? Slope of this is b. So slope of this line is equal to b, and this line is passing through, we know this line is passing through x bar y bar. So we can write equation of line of regression y on x as y minus y bar is equal to b slope x minus x bar. As we know, if the equation of straight line, it passes through to one point with slope m, so we write in this way. Now we just substitute the value of this b, which is equal to covariance xy by sigma x square, or you can write this is r sigma y sigma x into x minus x bar. We call this value r sigma y sigma x as byx, and we define this as regression coefficient y on x. We denote this by byx. So this value is, that means this value, that means this b, which is the slope of the line y is equal to a plus bx. This is the regression coefficient y on x. Similarly, we can derive equation of line of regression x on y as regression equation x on y, x is equal to a plus by is also passing through the point x bar y bar. But what is the slope here? Slope is 1 by b. So we write y minus y bar is 1 by b x minus x bar. So we rewrite this x minus x bar is equal to b y minus y bar. This time this is, we call this as bxy. So here b is not the slope, 1 by b is the slope. So regression coefficient x on y is 1 by b, and equation become x minus x bar is equal to bxy y minus y bar. Now we are having byx and bxy, that means regression coefficient y on x, regression coefficient x on y. We also know now this is equal to r sigma y by sigma x, that is, we denote this by byx or by2, this quantity, and similarly here we denote this by bxy or b1. But what actually it does, it measures the change in y corresponding to a unit change in x. This regression coefficient y on x, it measures the change in y corresponding to a unit change in x. Here regression coefficient x on y, what does it measure? The change in x to a unit change in y, change in x corresponding to a unit change in y. So now we are in the position to write various formula, and we write in a table byx and bxy regression coefficient. We have just derived, this is equal to this is equal to r sigma y by sigma x, and this is covariance xy by sigma x square. So we substitute the value of covariance and variance of x series. So 1 by n is cancelled out, and this is the formula by actual mean method for covariance. 1 by n is there, 1 by n is there, so that is cancelled out. So the formula is this. By direct method we are having the formula for covariance, this is sigma x square. Similarly, assumed mean method, here we call u is equal to x minus a, v is y minus b. This is change of origin. Regression coefficient, they are independent of change of origin but not of scale. If we change the scale, then there is a change in the formula, then you have to multiply, in this case, k by h. If k and h and k are the scales, change of scale in x and y. Similarly, we are having various formula for bxy, regression coefficient bxy. This is, now you can see You can learn very easily. This is covariance xy by sigma x square byx. This is covariance xy sigma y square. This is r sigma y by sigma x. This is r sigma x by sigma y. By actual mean method, the numerator part is same. There is a change in the denominator part. The role of x and y are interchanged now. So we write in the same manner. This is x minus x bar. This is y minus y bar. This is in terms of y. This is in terms of v. So these are various computational formula for regression coefficient byx and bxy. Thank you.